Okay, so dear students, we have this question out here. As a doubt, it says, in the given figure, PQRS is a square and SRT is an equilateral triangle. Prove that PT is equal to QT and angle TQR is equal to 15 degrees. Okay, and there's a hint also provided. See, so PQRS is a square, and then the other on top of it, the triangular shape is there. And equilateral triangle, the hint is all sides are equal. And so we can see a lot of triangles out here. It's the way we visualize the figure, isn't it? And squares, all the sides are equal, and each angle of the square is 90 degrees. So each angle of equilateral triangle is 60 degrees. So we'll see how to work about it. So we'll keep the hint for now. We'll just go with the figure now. So what I'll do is I'm going to just try to see if I can show it to you here. If not, I will try to write it in a separate platform. So let's see. See, it says in the given figure, PQRS is a square. All right. So I'll just like mark out that portion in, let's say, red. You can see, PQRS is a square. Yeah, PQRS. So PQRS. You can see what I'm doing here. I'm just marking that. Okay. So properties of a square, all sides are equal, isn't it? And of course, this is 90 degrees here and a 90 degrees here. And how does it help us? So this side is equal to this side. Anyway, it's marked in red, as in it's saying that we have that PS is equal to RQ or QR. Yeah. So we can say angle TSP is equal to angle, no, for now I still don't know. I'll put it across at just PS is equal to RQ. Why? Because it's a square, isn't it? So sides of a square. Sides of square. Moving on, and then this is 90, isn't it? That's angle RSP is 90. Angle SRQ is also 90 degrees because angles of a square. So we have to show that PT is equal to QT. That's when PT is equal to QT means we have to talk about two triangles. Which two triangles? I'll tell you. So if you also look a little more into the triangle part on top, see we have triangle TSR is equilateral, isn't it? It's given. Triangle TSR or SRT, it's given as SRT. Okay. So triangle SRT is equilateral. So if it's equilateral, what is the conclusion that I draw from this? Maybe I can just mark it out in, let's say, blue, so that you can understand what I'm trying to say. This side is equal to this side is equal to, of course, SR. Okay, it's a marked in. That's the side common to the square and the triangle. So because it's equilateral, we can say ST is equal to TR is equal to RS. And also, what about the angles? This is 60 degrees, isn't it? And here also it is 60 degrees. Yes. So look at angle TSP. The angle TSP will be 90 plus 60, isn't it? 60 plus 90. It is 150. You can just mention that angle TSR is equal to angle TRS is equal to 60. Why? Because equilateral triangle, isn't it? So that's one thing. Angle TSP is 60 plus 90, which is 150. Likewise, what is angle TRQ? It's an entire thing, isn't it? Angle TRQ is what? It is again 60 plus 90, which is also 150 degrees. So what does it tell me? So you have two triangles, isn't it? You have two triangles which are congruent. Yes. You see, you have to look at triangle TSP. TSP. Yes, angle TSP and the other triangle. I'll just mark the way I marked it with these two, isn't it? This and the other one is in black, no? The third side. This and this. See, I just extracted that from here. You can see. So triangle TSP, so angle TSP and TRQ. Yeah, they're congruent because TS are marked in blue, isn't it? TS is equal to TR. So TS is equal to TR. It's one side. SP is equal to RQ. That's the other side. And this angle, that's angle TSP is equal to angle TRQ. That's whatever 150, and that's our A, isn't it? Because of SAS criterion. Yeah, see, the two triangles are congruent by SAS. Because of SAS, the two triangles are congruent. And next, what follows is by CPCT. So what do we mean by CPCT? Now, once the two triangles have established congruency across the two triangles, I can say that, what can I say? That the two triangles are congruent means the corresponding paths are congruent. So now once I establish congruency, then I can say that, see, I'm writing it down here. So triangle TSP is congruent to triangle TRQ, and that's by SAS. So the next argument is by CPCT, that black sides will be equal, isn't it? The sides marked in black. TP will be equal to TQ. That's our argument, first one, TQ or QT, yeah? I proved the first part of the proof, yeah? Next is angle TQR is 15 degrees, TQR. Okay, so this is important. It's angle T, Q, and R. Now, if you look closely, actually angle TQR, okay, angle TQR will be isosceles. Why is it isosceles? See, if you look at the sides of a square, all the four sides are equal. That means SR is equal to SR. I'm just redrawing it here. See, SR is equal to RQ, isn't it? SR is equal to RQ. But this SR is also equal to TR. Why? Because the sides of an equilateral triangle, isn't it? So if you just look at, apply the logic, what do I get? SR is equal to RQ, yeah, because at the sides of the square. So also SR is equal to TR. SR is equal to TR. SR is equal to RQ because of the square. Yeah, properties of square. SR is equal to TR because of the equilateral triangle. That means I can use both the arguments and say RQ is equal to TR. RQ is equal to TR. So what is it? In my right angle, in my triangle TRQ, I'm just drawing an arrow mark. Can you see? So TRQ, what happens here? Angle TRQ is, triangle TRQ is isosceles because TR is equal to RQ. Isn't it? The blue and the red side becomes equal. If I'm just going to redraw that, it will be like this. TR is equal to RQ. So then the base angles will be equal, right? We are marking that. Yes, the main figure also, see, I'm marking it. Maybe I'll mark it in the color which you can visualize. In marking it in yellow. Base angles will be equal, isn't it? Huh. And now we have 60 plus 90 over here. I'll mark that in, let's say, green. 60 plus 90. So in this triangle TQR, triangle TQR, if you apply angle sum property, triangle TQR, if you're going to apply angle sum property, you will get what? 60 plus 90 is 150. 150 plus that each of the yellow angles, let me call them as x. 150 plus 2x is equal to 180, isn't it? So in other words, 2x is 180 minus 150, which is 30, or x is equal to 15. So x is equal to 15. X is nothing but angle TQR or angle TQR. Yeah, angle TQR is x, isn't it? TQR, this angle, see, angle TQR is 15 degrees. So you can also say TQR or QTR. Even QTR is the same angle. If they were to ask you what to prove that, it's the same logic, because angle TQR is equal to angle QTR. Okay, so here we have used actually three concepts. That is, one is properties of an equilateral triangle, properties of a square, and congruency, SAS congruency. Yeah, and of course the angle sum property, which is related to triangles as well. So I hope this part of the explanation has been clear to you.